Hi everyone, we're going to write an equation for each graph. These are graphs in sine and cosine, trig graphs. So basically we want to write something such as y equals absolute value of our amplitude, sine or cosine. This one happens to be cosine because it's a characteristic curve. That's where cosine starts. So this would be cosine. And then we're going to have our period x. So we can call this some k, or I'll just put kx. All right. So what we're going to do with this one is look at the center line here. It's right there. So we know the amplitude is 2 because it goes up 2 and down 2. So remember y equals 2 cosine. And then get our period, we'll just call the period as t, equals 2 pi over the complete rotation. So we know sine makes a complete rotation, or cosine goes down here and up to here. So that's a complete wave. So we're stopping at 4, 0 to 4. So we can divide that by 4. And that gives you pi over 2. So our equation is y equals 2 cosine of pi over 2x. Now for this one, we have sine. We know sine is more the zigzag. So for this one, that's a complete wave right there. Our center line is right here. And again, the amplitude for this is 2 because it goes up 2, down 2. So it's y equals 2, and it's going to be sine. Now my period for this stops at 4 as well. So it's going to be the same thing as that. And this is going to be pi over 2x. So it's a complete rotation. Pi over 2 is 90 degrees. So let's do a few more. We have to write an equation for this. We know it's cosine. It starts here. And a complete rotation, let me try to draw on here, would be from here to 8. The period, there's your center line. So your amplitude is 5. So you write y equals 5. The characteristic curve is cosine. And then to get your, that's going to be x sum kx, we take our period's going to be 2 pi. And since this stops at 8, over 8, and that equals pi over 4. So y equals 5 cosine pi over 4x. And next one is this one. All right, this one has a characteristic curve of sine. However, sine usually goes up like this. So this is a reflection over the x-axis. So basically for this one, we know it's sine. We know our amplitude is 2. So it's 2, the absolute value. However, since it's a reflection, we put a negative in front. And we know it's the characteristic wave is sine, so we're going to write sine. And it stops at 4, so our period is going to be 2 pi over 4, which equals pi over 2. So pi over 2x. It's just negative. Okay, and the next one is this one. This is the same thing, except it's cosine. Usually cosine starts here. So you're just reflecting here. If I do a complete wave, if it was here, since it's a reflection over the x, we know it's going to be negative, but our amplitude is 2. Amplitude is always positive. We know it's cosine, and then our period is 2 pi, makes a complete wave from 0 to 4. So that's going to be pi over 2x. Right, the next one are these two. So let's see. It's a cosine, it's a sine wave, and it completes at 1. a complete wave from 0 to 1. Amplitude is 3/4. So we're at y equals 3/4 sine, and then our period is 2 pi over 1, which is just 2 pi. So we have 2 pi x. All right, and this one, if we start here, let's see, let me do a different color. This looks like cosine. Again, it's a reflection, so go back up here. This is what it would be normally, but it's a reflection, so that's just going to be negative. Our period happens to be 5 over 2. We know it's cosine. It makes a complete wave from 0 to 2. So your period is 2 pi over 2, which equals pi. So that would be pi times x. All right, and what do we have here? We have one more. So this one, let's see what's going on with this one. For this one, you can see normally it looks like cosine. So if I draw a cosine, it would go up here, right down to here. And it's a reflection. So it makes a complete wave from here to here. Or we could say from negative. Let's do it this way. From here to there. There's your complete wave. So basically, what we did, it's the new center line. If you do draw your center lines at 1. So what we're going to do is add these two to find the, this is going to be 2 pi, or we're going to just, let's do it this way. Our angle, if we write this as y, equals, we know it's negative because it's reflected. And we're just going up 1 and down 1. So our amplitude is just 1. And then we have this some k x. And it's shifted up 1. So our problem is our k here. So let's see what that's going to be. What we're going to do is that our k equal 3/2, which equals 2 pi over our k. So that's going to be k equals 4 pi over 3 if you cross multiply. You can cross multiply here. So you're going to get, multiply those two, you get 4 pi equals 3k. So k equals 4 pi over 3. So your equation is y equals negative cosine of 4 pi over 3 x. And then we shifted this up by 1 because normally the cosine wave starts, our center line is right here at y equals 0. Now it's at y equals 1. So it's shifted up. So put your plus 1. And that's it. Thank you. Have a nice day. Bye-bye.